Okay, so this is going to get you to the back of your review sheet. The back of your review sheet is all over rationals. On 25 through 28, they ask you to find the domain. When you're looking for the domain, you're going to look at the denominator, and then you're going to try to figure out what would make that denominator equal 0. And then your domain is everything but whatever makes the denominator 0. So if I'm looking at this first problem, I'm focusing on 3 plus x. And I want to know what would make this number down here turn into a 0. So 3 plus what would be 0? Well, negative 3. The denominator is never allowed to be negative 3. So your domain is all real numbers except x cannot equal negative 3. 26 works the same way. This time I have 2 of them to look at. So what would make this be 0? And then I need to know what would make this be 0. So if this number were a 2, I'd have 2 minus 2, which would be 0, and 0 times anything is 0. So x cannot equal 2. If this number right here was a negative 4, then negative 4 plus 4 would be 0, and 0 times anything is 0. So x can also not equal negative 4. So your domain is all real numbers except x cannot equal 2, and x cannot equal negative 4. 27. On 27, I want to know what number could I plug in right here so that when I square it and subtract 9, I would get 0. Well, for this to be 0, this number would have to be 9. And what number squared is 9? Well, 3 squared is 9, but so is negative 3. So make sure that you do both, plus and minus. So x is all real numbers, except x cannot equal positive or negative 3. On this problem, I want to know what could I plug in right here so that when I add 1 to it, it would be 0. If I put 0 in here, 0 squared is 0, and 0 plus 1 is 1, so that doesn't work. A lot of people want to tell me negative 1. If I put a negative 1 here, a negative 1 times a negative 1 is a positive 1, and 1 plus 1 is 2. In fact, there's nothing that I can plug in right here that will make this bottom number be 0. So for this problem, there are no restrictions. The domain can be anything I want. So your domain is all real numbers. And you can write it using the symbol or negative infinity to positive infinity. So on the test, when they ask you about the domain, focus on the denominator, and you want to know what would make it be 0, and that's what it cannot equal. On 29 through 32, they're asking you to graph rational functions. Anytime they ask you to graph a 1 over x, you're going to remember this parent function. We've got horizontal asymptotes at y equals 0, and I have vertical asymptotes at x equals 0. There's going to be 2 points every time you graph. You're going to go to the middle of the asymptotes. You're going to go right 1, up 1, and draw a curve. Then you're going to go back to the middle and go left 1, down 1, and draw a curve. So every time you have a 1 over x, you're going to look at this parent function. If you have a 1 over x squared, we're going to look at this parent function. We have horizontal asymptote on the y, on the x, a vertical asymptote on the y. This time when you go to the middle, you go right 1, up 1, and draw a curve, and you go back to the middle and go left 1, up 1, and draw a curve. So every time you see an x squared function, a 1 over x squared, we're going to use this for our parent function. Okay, so here we go. On number 29, it's an x squared, so my graph is going to look something like this. That minus 2 is in parentheses, which means I'm going to go right 2. And then I have a plus 3 on the outside, so we're also going to go up 3. So when you're graphing these, to do your transformations, move the asymptotes first. So I'm looking right here, and I have got an asymptote at 0, but I'm going to move it right 2. So I'm going to go to the right 2 and draw a new vertical asymptote. And then I'm going to take the one that was normally right here at y equals 0, and I'm going to go up 3. So here's my new set of asymptotes. From there, I'm going to go back to the middle. And because it's a positive 1 on top, I'm going to go right 1, up 1, and left 1, up 1 from the middle. So right 1, up 1. Go back to the middle, left 1, up 1. So there's my 1 over x squared shifted 2 to the right and up 3. Number 30, you'll notice there's no squared. So this time I'm looking at this 1 over x parent function. This plus 2 is underneath, so it's like it's in parentheses. So we're going to do the opposite and go left 2. This minus 3 is on the outside, so I'm going to go down 3. So again, we're going to start by moving the asymptotes first. So I'm going to go left 2, and then I'm going to go down 3. So there's my asymptotes. They cross right here. Now if it's the parent function, I go to the middle and I go right 1, up 1, draw a curve, back to the middle, down 1, left 1, down 1, draw a curve. Since this is just a positive 1 on top, I'm going to follow that same pattern. I'm going to go to the middle and go right 1, up 1, and draw that piece. Then I'm going to go back to the middle and go left 1, down 1, and draw that piece. Okay, number 31, if you look at the bottom, we see it's an x squared. There's nothing going on right here, so it's not going left or right at all. There's nothing out here, so it's not going up or down at all. So the asymptotes stay on the x and the y axis. What is different is this number up here. There's a stretch. So it's an x squared, so I'm thinking about this. Instead of going right 1, up 1, I'm going to go right 1, up 2 if it were a positive. But because it's a negative, that means it's going to reflect over the x, and that 2 is going to make it do a stretch that's vertical. So from the middle, I would normally go right 1, up 1. Because it's negative, from the middle, I'm going to go right 1, down 2. And then I'm going to do the same thing. I'm going to go back to the middle, and I'm going to go left 1, down 2. So I took my parent function, I flipped it upside down, and then instead of going 1, I went 2. All right, last one of these, 32. If you look at this, there's not an x squared. That means it's a 1 over x, so it's going to look something like this. There is a number in the denominator. It says -1, so I do the opposite. So I'm going to go right 1. On top, there's a negative, so it's going to reflect. So the right side used to be on the top, and the left side used to be on the bottom, and they're going to flip sides, okay? And there's also a vertical stretch of 2. So the only asymptote that moves is I'm going to go right 1. The horizontal one stays right here where it was. Okay. Normally, when I do a 1 over x, I go right 1, up 1. Because it's a negative, I'm going to go right 1, down. And because it's a -2, I'm going to go right 1, down 2. So the right side is going to be on the bottom now. I'm going to go back to my middle, and I'm going to go left 1, up 2. So I took these two arms, the right side is now on the bottom, the left side is now on the top, and instead of going right 1, up 1, I went right 1, down 2 because of that negative right there. Okay, so on the last section, we're going to go ahead and get rid of number 35 and 36. After I keyed the test, I found out we don't really need to do any of that hard, so we're going to keep it a little more similar to the test here. So there are four things to do for each of these two equations. I need to find the vertical asymptote, the horizontal or oblique, the y-intercept, and the x-intercept. When they ask you to find the vertical asymptote, you need to factor and simplify. Once you've simplified, you're going to set the denominator equal to 0 and solve. So on number 33, you'll notice there's nothing to factor here. If I pulled out a GCF right here, I would have x plus 2, so nothing cancels. So since there's nothing to factor, I simply set the denominator equal to 0, and I solve. So if I solve that, I get x equals 5. Done. I'm going to do the exact same thing right here. There's nothing to factor, so I just set the denominator equal to 0, and I solve. So I take the square root of 0, which is just 0. Okay, so those two are done. When they ask you to find the horizontal or oblique asymptotes, you're going to use the acronym Bobo, Botten, Eats, DC. And anytime I ask you Bobo, Botten, Eats, DC, you're focusing on the exponents, and the biggest exponent on the top and the biggest exponent on the bottom. So on 33, the biggest exponent on top is 1, and the biggest exponent on bottom is 1. So are my exponents bigger on top, bigger on bottom, or are they the same? When your exponents are the same, the DC stands for divide the coefficients. So this coefficient is a 3, this coefficient is a 1, and 3 divided by 1 is 3. Done. 34 is going to work the same way. I have an exponent of 1 on the top, an exponent of 2 on the bottom. So is it bigger on the top, bigger on the bottom, or are they the same? Where it's clearly bigger on bottom, so when it's bigger on bottom, it's called BOBO, which means y equals 0. So your answer is y equals 0. Okay, to find your y-intercepts, you let x equal 0 in the equation, and you solve. So if I let this x be 0, I have 3 times 0 plus 6 over 1 times 0 minus 5, which is going to leave me with just negative 6 over 5. 0 plus 6 is 6. 0 minus 5 is negative 5. 6 over negative 5 is negative 6/5. You're going to do the exact same thing here. If I plug in a 0 up top, I get negative 2. If I plug in a 0 on bottom, I get 0. Negative 2 divided by 0 is undefined. So this one has no y-intercept. It doesn't exist. It never touches the y. To get your x-intercept, you let the y equal 0 and solve. Remember, these are your y's. So I'm going to do my work, I guess right here at the bottom. So I'm going to say 0 equals 3x plus 6 over x minus 5. So to get x by itself, I need to take it out of the bottom. So I have to multiply both sides by x minus 5. I get x minus 5 times 0 equals 3x plus 6. This whole side just equals 0. And I'm going to solve. So I subtract 6 and divide by 3. So if I move 6 over, we get negative 6. 3 divided by negative 6 is negative 2. Your x-intercept is negative 2. So an easy way to remember this is anytime you have a rational and you're trying to solve for an x-intercept, just solve the numerator for x. So let's go do that right now. So I just told you a shortcut for doing this is just solve the numerator for x. So 5x minus 2 equals 0. So if I move the 2 over, we get 5x equals 2. So x equals 2 over 5. And there is your x-intercept. This should get you ready for the test. I would make sure I do the practice test also and grade yourself. Good luck. Study hard.